In this video, we'll talk about what are equivalents and how to perform calculations using equivalents. A lot of students in chemistry don't work with these types of calculations, but they're really useful for students in allied health. So let's get right to it. An equivalent is the amount of an electrolyte or an ion that provides 1 mole of electrical charge. I just tell students think of it as a mole of charge. So 1 mole of sodium ions, and the sodium ion has a charge of +1, would be considered one equivalent. 1 mole of chloride ions. Now, even though the chloride is an anion and has a negative charge, which is different than sodium, which has a positive charge and is a cation, it is still considered one equivalent. Why? There is 1 mole of electrical charge, and it doesn't matter whether it's positive or negative. So 1 mole of calcium, now even though I only have 1 mole of the calcium ion, each calcium has a 2 plus charge. So 1 mole of calcium would give me actually 2 equivalents because there's 2 moles of charge. 1 mole of iron 3 would give me 3 equivalents. So you can always just look at the charge to determine the number of equivalents per mole. You could even do this with polyatomic ions. For example, if I had 1 mole of sulfate and the sulfate ion has a 2 negative charge, then I would have 2 equivalents. Let's make sure we know what we're doing. In 1 mole of iron 3, there are how many equivalents? 3 equivalents. In 2.5 moles of sulfate, there are how many equivalents? This is a little bit different. I didn't say 1 mole because if it was 1 mole, we would know there'd be 2 equivalents. So you might have to use the conversion factor method to do that. The easiest way to do that is to set up a mole ratio. In 1 mole of sulfate, because there's a -2 ion, there's 2 equivalents. I go from 2.5 moles of sulfate by putting the conversion factor where the unit of moles goes in the denominator and easily cancels out. 2.5 moles times 2 equivalents per mole gives me a final answer of 5 equivalents of sulfate. You could do this as well if you were given grams of a compound or an ion. Why are equivalents so important? Well, if you work in the health field, you'll realize that a lot of the saline solutions are measured with milliequivalents per liter. So typically, students have to be somewhat comfortable with these types of calculations. Another thing that I'd like to mention is equivalents are an important calculation because in your body you have ions and electrolytes. We have to make sure that the electrolytes are balanced. What do I mean balanced? You have to have the same amount of positive charges as you do negative. You'll see in this example that in a Ringer solution, there are several different cations, sodium, potassium, and calcium. There is only one example here of anion, chloride, but all of the milliequivalents have to equal the same for both the cation and the anion. There has to be the same amount of positive and negative charges in terms of milliequivalents. I hope this helps you understand the concept of equivalence, how to perform their calculations, and where you find them. I'll see you next time.